Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of BITSAT Practice, we're going to be looking at some questions of mathematics asked in previous years of BITSAT. Today, we're going to be looking at some questions of the chapter probability, which are asked in BITSAT. So, before we start off with the questions, I urge you to watch the entire video completely because we'll be discussing various techniques as well as reasons why the correct answer is the correct option. So that means you'll have more, experience with similar questions that may come up in your exam. So on that note, let's start off with the first question. In a binomial distribution, the mean is 4 and the variance is 3. Then we need to find out its mod. So its mode is either 5, 6, 4, or none of these. So which of these options is correct? So first of all, remember this is a binomial distribution. So in a binomial distribution, the mean is represented by the formula NP and its value is 4. The variance is represented by the formula NPQ and its value is 3. Now over here, N stands for the number of trials and the other letters P and Q are the outcomes. So you either have a positive outcome or a negative outcome. So now we know the value of NPQ as 3 and we know the value of NP as 4. So therefore the value of Q will be equal to NPQ divided by NP. That is equal to 3 divided by 4. And since P is the successful outcome and Q is the failed outcome, we can write P as equal to 1 minus Q. So that is 1 minus 3 divided by 4, which is 1 divided by 4. So since we know that NP equals 4, we can write that N times 1 by 4 will be equal to 4. So that means N equals 4 times 4, which is 16. So we have 16 trials and the successful outcome is 1 by 4 and the failed outcome is 3 by 4. Now, remember that we need to find the mod of this function. So at P of x equals r, if the function is at its maximum value, then r is the mod of the function. It's the mode of the function. So let's find out the conditions for mode in the binomial distribution. So in binomial distribution, we can see that n plus 1 times p minus 1 is less than or equal to the mod, which is less than or equal to n plus 1 times p. So the value of the mod ranges from n plus 1 times p minus 1 and n plus 1 times p. So we know the values of n and p. Let's put in those values. N is 16, so 16 plus 1 times 1 by 4 minus 1 is less than or equal to r, which is less than or equal to 16 plus 1 times 1 by 4. So 16 plus 1 is 17, so 17 divided by 4 minus 1, less than or equal to r, less than or equal to 17 divided by 4. 17 by 4 minus 1 is 17 by 4 minus 4 by 4. So basically it's 17 minus 4 divided by 4, less than r, less than 17 divided by 4. So that means we have 13 by 4 less than or equal to r less than or equal to 17 by 4. So the value of the mod ranges between 13 by 4 and 17 by 4. So if we were to divide 13 with 4 and 17 with 4, So 12 by 4 is 2, so therefore 13 by 4 will be, 2 times 1 by 4. So that is 2. It will be 3 times 1 by 4. So 3 plus 1 by 4, so that's 3.25, which will be less than or equal to r, which will be less than or equal to 17 by 4. So we know that 16 by 4 is 4, so therefore 17 by 4, if we were to divide it, you will get 4.25. So 3.25 is less than or equal to r, less than or equal to 4.25. So we need to find the mod. Now, r, the mode, is always a whole number. So that means the value of r must be a whole number that is between 3.25 and 4.25. The only whole number there is 4, so therefore option C, 4, is the correct answer. Now, let's look at another question of probability. The early question was from 2018. This one is from 2017. A random variable x has the following probability distribution. For the events e equals x is a prime number and f equals x less than 4, we find the value of E union F, the probability of E union F. So we know that x is a prime number. That will be the event E. So whenever x is a prime number, the event E occurs. So if you want to find the probability of E, you will find the probability of 2 plus and add it to the probability of 3 and also to 5 as well as to 7, because those are the prime numbers between 1 and 8. So we will add these probabilities. P of 2 is given as 0.23, P of 3 is given as 0.12, P of 5 is given as 0.20, P of 7 is given as 0.07. So we can just remove the decimals and then add them accordingly. 23 plus 20 gives you 43. 43 plus 7 gives you 50. 50 plus 12 gives you 62. So P of E will be 0.62. Now, we know that F is the event where x is less than 4. So that means P of F, the probability of F occurring, will be the sum of P of 1, P of 2, and P of 3. So P of F is P of 1 plus P of 2 plus P of 3, because all these numbers are less than 4. So now let's add those probabilities. So P of F will now be equal to 0.15 plus 0.23 plus 0.12. We can just check that out here. 0.15 is P of 1, 0.23 is P of 2, 0.12 is P of 3. Now we will add these values. So 15 plus 12 gives you 27, 27 plus 23 gives you 50. So therefore P of F will be 0.50. So we now know the values of P of E and P of F. We need to find P of E union F, but in order to find that particular value, we also need to find out P of E intersection F. So what is E intersection F? Well, the event E intersection F can be defined as x is a prime number and x is less than 4. So that means the probability of E intersection F occurring is the sum of the probabilities of x equals 2 and x equals 3. So P of 2 plus P of 3 will give you P of E intersection F, because 2 and 3 are prime numbers and they are less than 4. So that means you'll have 0.23 plus 0.12. So 23 plus 12, 23 plus 10 gives you 33, plus 2 gives you 35. So 0.35 is the value of P of E intersection F. So now that we know P of E, P of F, and P of E intersection F, we can easily find out P of E union F. So P of E union F can be represented as P of E plus P of F minus P of E intersection F. So union means every element in between of E as well as F. So we can eliminate the overlapping elements because they occur twice when we do P of E plus P of F. So that's why this formula comes to life. So the value of P of E, that is 0.62. The value of P of F is 0.50. And the value of P of E intersection F is 0.35. So 62 plus 50, that will be, let's add them up. So 0.62, 0.50. So you have 2, 6 plus 5 is 11. 1 goes to the next digit. So we have 1.12. We will now subtract 0.35. So 12 minus 5 gives you 7. 10 minus 3 gives you 7. So therefore, the correct answer for P of E union F is 0.77. 0.77 is the correct answer. And if we look at the following options, you can see that option B is the correct answer. Option A is incorrect because that is the value of P of F. Option C is the value of P of E intersection F, and option D does not occur because when we add the probabilities correctly and we compute the value of P of E union F, nowhere we will find the digit 0.87. So therefore, option D is also incorrect. Let's look at the last question of this episode. This one is from 2016. A man takes a step forward with probability 0.4, and he takes a step backward with probability 0.6. The probability that at the end of 11 steps he is 1 step away from the starting point is. We have the 4 options given here. We need to find out which of these is correct. Now, remember, when we take a step forward, the probability is 0.4, and when we take a step backward, the probability is 0.6. So the sum of the probabilities will be 0.4 plus 0.6, which is equal to 1, as it should be. So we just tested it out so that it is correct. So now, since we know that the sum of the probabilities of the two events equals 1, we can find out that this is a case of binomial distribution. And there is a good reason why we need to find out whether this is a binomial distribution, because then we can use the binomial theorem in order to solve the problem. Now, moving on, we know that probability of a successful step forward is 0.4. We can write that as 2 by 5. And the probability of a step backward is a failure, so that's 0.6, which we can write as 3 by 5. So the value of P is 2 by 5, and the value of Q is 3 by 5. So we take those as the two binomials here, as the two terms here. So those are the two events that happen, a successful step forward or a successful step backward. Now, moving on, in the question, it says that at the end of 11 steps, he is 1 step away from the starting point. So that's the condition that we need to take. Now remember, in the question, it says 1 step away. So 1 step away can refer to 1 step forward, or it can represent 1 step backward from the starting point. So that means we have 2 separate conditions for the given condition in the question. So therefore, we have to add the probabilities of 1 step forward as well as 1 step backward. Now, in order for this condition to occur, the difference of 1 must be present between P and Q. I mean, n of P, the number of times P occurs and the number of times Q occurs. So that means we have n of P equals 6 and n of Q equals 5. Or we can have n of P equals 5 and n of Q equals 6. So we have 6 plus 5 or 5 plus 6. And here we need to find out the required probability. Now, since we have both conditions, the required probability will be the sum of probabilities of one step forward as well as one step backward. And in order to represent those probabilities, since we have a binomial distribution here, we will use the binomial theorem. So we can write 11c6, p raised to 6, q raised to 5, plus 11c5, p raised to 5, q raised to 6. So this is basically, we just apply the values of NCR, a raised to r, b raised to n minus r. So over here, the value of n is 11. We have total 11 steps, and we can take 6 successful steps or 5 successful steps. So that's why we have to add both of them. So if the number of successful steps is 6, then its probability is p. So p raised to 6 and q raised to 11 minus 6. So that's the number of failed steps, which is 5. And similarly, we have 11 total number of steps. The required steps is 5. So 5 successful steps and 6 steps backward. So now what we're going to do is we're going to take things common out from here. Now in the binomial theorem, we know that NCR can also be represented as NC times n minus r. So if we take 11c6 and 11c5, we notice that they both have the same values, because, for example, if we were to take 11c6, so that's 11 into 11 into 10 into 9 into 8 into 7 into 6, and in the denominator it'll be 1 into 2 into 3 into 4 into 5 into 6. So as you can see, 6 gets cancelled. What we have is 11c5. So therefore, we can find out that the value of 11c5 and 11c6 are the same. So we can take 11c6 as common from both the terms. We also know that both terms have p raised to 5, and we also know that both terms have q raised to 5 as common. And so in the bracket, we will have p plus q. So let's take out 11c6 or 11c5. So its value will be 11 into 10 into 9 into 8 into 7 divided by 1 into 2 into 3 into 4 into 5. And we have p raised to 5. So p is the number of steps, the probability of steps forward. So that's 2 by 5, and it is raised to the power 5. Similarly, we have 3 by 5. That's the probability of steps going backwards. So that will be also raised to 5. And inside the bracket, we will have 2 by 5 plus 3 by 5. The sum of probabilities will always be 1. So that becomes 1. So anything times 1 is itself. Now, we know that 10 can be divided by both 2 and 5. And we also know that 9 can be divided by 3. We also know that 8 can be divided by 4. So you have 11 times 3 times 2 times 7 in the numerator and 1 in the denominator. So 11 into 3 into 2 into 7 divided by 1 times, we know that the two probabilities can be represented as 2 raised to 5 divided by 5 raised to 5 into 3 raised to 5 divided by 5 raised to 5. And the other bracket is now shortened to 1, and therefore times 1 means itself. Now, 3 times 2 gives you 6, and 6 times 7 gives you 7 6 are 42. So now we have 42 times 11. So 2 times 1 is 2. So let's do that multiplication out here on the left side. So we have 42 times 11. So 2 times 1 is 2, 4 times 1 is 4, 2 times 1 is 2, 4 times 1 is 4. We have a 0 here. We have 2, and then 6, and then 4. So therefore, the product of 11, 3, 2, and 7 is 462. And we can also simplify the other side, the side with the fractions. So the denominator will be 5 raised to 5 into 5 raised to 5. So that can be written according to the law of exponents: a raised to n into a raised to n into a raised to m equals a raised to n plus m. So here we have the base as 5, so therefore we can add the exponents together in the denominator. So 5 raised to 5 plus 5, so that's 5 raised to 10. So in the numerator we have a raised to n times b raised to n. That will be equal to a times b, the whole raised to n. So in the numerator we have 2 and 3, both are raised to the power 5. So we get 2 into 3 times 2 into 3 raised to the power 5. So we have 6 raised to 5. Now if we were to simplify this further, we can write 6 divided by 5 square, which is 25. This particular fraction is raised to the power of 5. So 462 times 6 by 25 raised to 5 will be our final answer. And if we look at our options, you can see that option B is the correct answer. Option A is incorrect because since we do get 2 raised to 5 times 3 raised to 5 divided by 5 raised to 10, but then the part of 11C5 is being ignored here. So option A is incorrect. And in option C, the combination here leads to incorrect answer. So option C is incorrect. And since we have found out the value of B to be the correct answer, so option D also becomes incorrect because this says none of the above, whereas we do know that B is correct. So that is the correct answer for this question asked in 2016. Option B is the correct option. That concludes this episode of BITSAT Practice. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. You can always share your views in the comment section down below, and you can also get the latest updates by hitting the bell icon again below the video. So until the next episode, take care, stay safe, bye-bye for now.